Hello viewers, good morning. In the last video, we have discussed about the maxima and minima up to question number 16. So now we will see question number 17 in this video, 17 onwards. So in question number 17, it is given that it is asked a square piece of tin sheet, it is of side 18 centimeter, is to be made into a box without top by cutting a square from each corner and folding up the flaps to form the box. What should be the side of a square to be cut off so that the volume of the box is the maximum possible? So if we take a square piece of tin sheet and it is given to it is an industrial question, industrial purpose. So how we can, with minimum material, we can give the maximum output? So that kind of question. So a square sheet of tin piece is given to you and it is asked that you have to make it at a open box by cutting the side of the tin sheet. So that what will happen if we cut the side, a square from each corner, then what will happen? It will become an open box. If you cut the side, this side has to be cut off. Look at that. If we want to make this one, then this portion, what is happening? This has to be cut off so that it can become like that. Okay. So what this square shape? If I show you in the figure, look at that. If you fold it flat on this place and even here also, so what will happen? This portion has to cut off from each corner. There will be a square. This portion if we cut off, then if we fold this side, then what will happen? A box will form. Okay. So that box, it should contain, it is an open box, it should contain maximum. So how much from each corner we have to cut? What square? What should be the side of the square we have to cut off, so that it can become, its volume will become maximum, means maximum liquid or whatever it is, it can hold. So how much this side should be there, that this square we have to cut? It is given that its side is 18 centimeter. Total length is 18 centimeter is the length. It is a square, so here also it is 18. So how much you have to cut? We do not know. So we will take, say, x centimeter or whatever it is. X centimeter we have to cut. So what part will remain? How much this will remain? If total is 18, here x we are cutting, here also x we are cutting, so it will remain 18 minus 2x. And what will be the breadth? Here also it is 18. Length or breadth both are same. Here also it is 18, so 18 minus 2x. And what will be the height of that box? Height of the box will become, here this is how much? This is x, so height of the box will become x centimeter. So what will be the dimension of this box? 18 minus 2x, and height is x centimeter. So what you have to do it, let x centimeter, x centimeter square should be cut off from each corner. Okay. Therefore, the length, breadth, and height of the box will become then the dimension or the length, breadth and height of the box will become 18 minus 2x, 18 minus 2x and xn. Then what will be the volume? What is volume of that? It will become a cuboid. So what is the volume? Therefore volume of the box will be volume of the box. So any symbol you can give. So V will be equal to length into breadth into height. So length into breadth into height. So it is 18 minus 2x into 18 minus 2x into x. This much centimeter. This will be the volume of the box. Now, how we can show that, or how we can find that what is the value of x, so that the volume of the box will become maximum. So what we will do? Say this is our function is b is equal to 18 minus 2x whole square into x. What we have to do? We have to differentiate with respect to x. First differentiation, we will compare with 0. We will find the value of x, and we will do double differentiation and we will put that value of x. If it is negative, then we can say yes, for that value of x it is maximum. Okay, so I am running these things. So we have to show that volume is maximum. So we will do differentiating with respect to x. What will be that? Or d dash we can write, or dv dx we can write. dv dx will be equal to, or this one you can make it little simplification also. If it is 18 minus 2x whole square, so a minus b whole square, a square means 18 square is 324 into x minus 18 to the 36 into 2 is 72 x square plus 4 x cube. Okay, so if we just expand it, we can get this one, so that differentiation will become easier. Okay, so what will remain if we do the differentiation of that? So it is 324 minus 144x plus 12x square. Okay, alright. Now we will compare with 0. Let dv dx is equal to 0 implies, we can write like that, 12x square minus 144x plus 324 is equal to 0. 12 can be taken common, so it can be x square minus 12x plus 12, 27 is equal to 0. Okay, 12 we have taken common and divided, so it is, this will remain. So what will be the value of x? This can be, here it is 27, here it is minus 12, so 9 and 3, so it can be x minus 9 into x minus 3 equal to 0. Therefore x is equal to 9 or 3. Therefore x is equal to 9 or 3. Now which value is possible? Both values may not be possible for that. If x is 9, here also 9, here also 9. So from 18 if it is subtracted, it will not remain anything. So 9 is not possible. You can see from the given question also. So 9 is not possible, so x is equal to 3. Therefore x is equal to 3. Therefore x is equal to 3, since x not is equal to 9. 9 is not possible for that. Now x is equal to 3 we have got it. So we have to check the double differentiation at x is equal to 3 whether it is negative or not. If it is negative, you can say it is maximum. So what we will do? Double differentiate. So again differentiating which one? dv dx with respect to x. So again differentiating with respect to x. What we will get? d square v by dx square. So what will happen in that case? If dx we have got this one, so this will become 0. Here it is minus 144 plus 24x. 12 to the 24x. Now what you have to see? Double differentiation at x is equal to 3. Therefore dv dx or d square v by dx square at x is equal to 3. What we will get? It is minus 144 plus 24 into 3. 24 3 is 72. So which is minus 72, which is less than 0. Okay. Now what you can say? You can say volume is maximum at x is equal to 3. Therefore volume is D is maximum at x is equal to 3. So here what should be? It is asked the question how much you have to cut from each corner. Therefore 3 cm square you have to cut from each corner, so that volume of the box will become maximum. Therefore 3 cm square, 3 cm square should be cut off. Should be cut off from each corner of the thing. From each corner so that volume of the box is maximum. So that volume of the box is maximum. So write the complete answer line, because this kind of questions are of 5 marks. So you have to write the complete answer properly and answer line also properly, so that examiners will be happy with your answer. So this way we can proceed to the next question also of same kind, that instead of square it is given it is a rectangle. It is a rectangle of side 45 cm by 24 cm, and we have to cut the square from each corner. Similar kind of question, you can try that one. Other things are same. We will go to the next question, question number 19. Okay. So what is given in 19? So in question number 19, it is given, show that all rectangles inscribed in a given fixed circle, the square has the maximum area. It means a fixed circle is there. Inside there may be different types of rectangles. One rectangle may be like this way, another that way. Many ways rectangles can be. But among the rectangles, square will have maximum area. If you make a square inside this circle, then it will have maximum area. We have to show it. Okay. So how we can do it? A circle is given, it is fixed. Let R be the radius of the circle. Okay. And ABCD be a rectangle. So we'll write let ABCD be a rectangle inscribed in a circle of radius r. Radius r. Okay, radius r or whatever it is, radius r. Now, if this is radius, then this, since it is a rectangle, its each angle is 90 degree. Definitely, the diagonal of the rectangle will pass through the center of the circle, because this is 90 degree. Angle on the semicircle is 90 degree. Okay, so definitely the diagonal will pass through the center of the circle. So what will be the diagonal? Diagonal will be 2r. If we take, say the here angle is formed, if we take this angle as theta, then by using trigonometry we can find what is the length of AB, what is the length of BC. Is it? By using trigonometry we can find or not? Yes, because it is a right triangle, because this angle will become 90 degree. Okay? So in a right triangle, if this angle is theta, so what this BC will become? BC will become twice r sin theta, and what AB will become twice r cos theta. Okay, because we know that trigonometric relations, trigonometric ratios, base by hypotenuse is cos, perpendicular by hypotenuse is sin. So in that case we can find out that. So we will take that angle CAB is equal to theta. If we take angle CAB is theta, therefore what will be AB is equal to? Therefore AB will be equal to 2r cos theta, and BC is equal to 2r. BC is 2r sin theta. Okay. Now, what is the area of this? It is told it has maximum area. What is the area of this rectangle? Length into breadth. So AB into BC. Therefore, area of rectangle is equal to AB into BC. So what will happen? 2r cos theta into 2r sin theta. So 2r cos theta into 2r sin theta. So what we can write this one? Look at that. R into r is r square, and 2 sin theta cos theta we can write it as sin 2 theta. We can make it simplified. So it will remain 2r square sin 2 theta. So this is our area of the rectangle. If we consider area of rectangle, say A also. So A is equal to 2r square sin 2 theta. Now we have to show that this, for since if it is a square, means AB and BC we have to show it equal. Okay. For what value of this, it will become equal, because R is fixed. It is a fixed circle. So R is fixed, R is constant. Alright? We have to think about that theta. Means what should be the value of theta, so that these two values are same. If it is same, then it can become, the rectangle can become a square. Okay? Our target is that. So what we have to do it? We have got A is this one. We will do the differentiation. So differentiation on which respect we have to do? Differentiating. Because R is constant, we have to differentiate with respect to theta. Okay? So differentiating with respect to theta. Differentiating with respect to theta. You can give it number 1 also. Differentiating 1 with respect to theta. What we get? dr theta. So what this will become? This is constant, so 2r square is constant, and sin 2 theta. sin 2 theta will be cos 2 theta into 2. So it will become 4r square cos 2 theta. Okay, 4r square cos 2 theta. Now we will compare this one with 0. First derivative we have done it. We will compare with 0. Let dr d theta is equal to 0 implies 4r square cos 2 theta is equal to 0 implies cos 2 theta is equal to 0. So when cos 0, where it is cos 1 0 at pi by 2 and 90 degree cos 0. So 2 theta is pi by 2. This implies 2 theta is pi by 2. So theta is equal to pi by 4. Theta is pi by 4. Okay. Now at pi by 4, if we do the double differentiation at pi by 4, if it is negative, we can say it is maximum. Okay. Now if it is pi by 4, so AP and BC are whether they are same or not, that also we will get this one. If it is pi by 4, so 2 are sin theta and 2 are cos theta. If sin theta is sin pi by 4, sin pi by 4 and cos pi by 4 are same value. So yes, so it will become AB and BC will become equal. Now we have to show that it is maximum. So how do we do it? Again differentiating with respect to theta. Again differentiating with respect to theta. So d square a by d theta square. So it is here d theta. Here 4r square is constant and cos 2 theta. Cos theta is minus sin theta. So cos 2 theta is minus 8r square sin 2 theta. Okay. Now when theta is pi by 4, therefore d square a by d theta square at theta is equal to pi by 4. What we are getting is minus 8 r square sin pi by 2. Sin pi by 2. So sin pi by 2, 2 theta it is. So 2 into pi by 4 it is pi by 2. So sin pi by 2 is 1. So what we are getting? This is equal to minus 8r square. So it is less than 0 definitely because it is constant. It is negative. So it is less than 0. Therefore area is maximum when theta is equal to pi by 4. Therefore area is maximum. Area is maximum when theta is equal to pi by 4. Now we have to show that this we have got it. This theta if it is pi by 4, it is area is maximum. Now we have to show, first it was given it is a rectangle. We have to show it is a square. It is asked that among all the rectangles we have to show that square has the maximum area. Now how we can show it is a square? The rectangle can be a square if its sides are adjacent sides are equal. So therefore AB will be equal to 2r cos theta. So this is equal to 2r into cos pi by 4. So how much it is? Cos pi by 4 is 1 by root 2. So it is root 2r. Root 2r. And this is equal to 2r sin theta. So it is 2r into sin pi by 4. So it is also sin pi by 4 is 1 by root 2. So root 2 it will become root 2r. So now since AB and BC are equal, AB and BC are equal, adjacent sides are equal, the rectangle is a square. We can write, since AB is equal to BC, AB is equal to BC, therefore ABCD is a square. So now what we have shown that among all the rectangles inside a circle, inscribed in a circle, square has the maximum. Okay, the same question in different ways also it can be given, same type questions. Okay, we have to show that the greatest square can be inscribed in a circle with radius r has the side root 2r. So that way also equations can be given. So this kind of questions are very important for the exam point of view. Okay, hence we can write that therefore ABCD is a square which has maximum area. Okay, so this kind of questions you try more. Thank you for watching the video.